Following is my conversation with Prudence Ferreira. Prudence is a passive design building consultant and the former president and current board member of PHIUS. We talk about passive building design, resilient housing, and the power of engineering. This is the Kathleen Sessions podcast, and you can find me at thekathleensessions.com. I hope you enjoy my conversation with Prudence. So, define passive design.
So passive design, I would define as a climate-specific and cost-optimized set of building science principles that will get any kind of building to a very high efficiency, low carbon performance, and as a pathway to net zero that's the most logical and science-based. So I feel like passive design is particularly important right now because we have very limited resources. We have increasing population. We're struggling. Many of our more progressive cities and jurisdictions are planning to do carbon neutral cities. University campuses are doing that as well. And there are a lot of different guidelines and certifications out there, and all of them have something to contribute to sustainability. But in my mind, the simplicity, as you mentioned, of Passive House and its building science focus really gets us to where we need to go with the least fanfare and the most direct efficacy. It really is a place where the rubber meets the road, if you will. And as we are both retrofitting existing building stock and constructing new buildings, having a focus on those building science principles, which we know are effective and they're not complex, really helps us have confidence that we're designing these buildings in a way that they will be assets for us in the future rather than liabilities.
And can you talk about what are some of the components that make up passive design? So if I'm going to build a house, we'll keep it simple because, if I'm going to build a house, what are the things I would do that would move me toward passive design or possibly certification? I mean, what are the elements involved?
Well, if you start with looking at the building site, what we're essentially doing with Passive House design is we're balancing the flows of resources into and out of the site and on the site, the building. And what that means is we're looking at the flux of heat. We're looking at the flux of light or solar gain. We're looking at the occupants that are going to be in the building. And we're looking at the equipment that's going to be in the building. And all of these need to be balanced. Now, the means by which we balance these are the Passive House principles, the building science principles. Now, if you're building a house in the northern part of the U.S., in a place where it's quite cold and snowy, one of the building science principles that we use is continuous insulation. So if we're in a cold climate, we're going to use more insulation than we would if we're in a warm climate. Another one of the principles that we use is avoidance of thermal bridging. Thermal bridging is where we have two components of a building that are coming together, whether it's a floor and a wall, or a roof and a wall, or a wall and a window. And anytime we have interruptions in the continuousness of the building enclosure, that's a potential place where we can have short-circuiting of that insulation layer by structural or connective elements that are more conductive than insulation, like metal or wood. And so in these areas, we try to pay really special attention as early as we can in design to eliminating the thermal bridges or mitigating them by using materials that are less conductive. And those thermal bridges are much, much more important in cold climates than they are in warm climates. The other building science principle that we're using is energy recovery ventilation. We want to have fresh air in these buildings. We want indoor air quality to be very high. The next building science principle I will mention is air sealing. And so anytime you're going to seal up a building to separate it from the environment, which reduces pollution, reduces intrusion of moisture, which can cause indoor air issues as far as mold, starting to erode away the building assemblies. Anytime you're doing that, you need to make sure that you have fresh, filtered, conditioned air inside the building. So those two principles go hand in hand. Those have to be implemented together. You can't do one without the other. So energy recovery ventilation is a method of bringing fresh air into the building through a core that is recovering temperature and sometimes humidity. If it's an energy recovery ventilator, it's doing both sensible temperature and latent or humidity. If it's a heat recovery ventilator, it's only exchanging temperature. It's not exchanging anything else. So depending on which type of device you have, which depends on which climate you're in, as you're bringing that fresh air in, you will either be adding humidity to it or subtracting humidity from it, and equalizing the temperature. So if your outdoor temperature is cold and it's in the heating season, you will be adding heat back into that fresh air from the heat that is going out of your stale air in your building. And the way that these devices work, they're quite remarkably, actually. They typically recover 9 to 13 times the amount of energy as it takes to run them. So they're very efficient. The fans are very efficient. The recovery cores for HRVs are passive. If you imagine a radiator, it's a bunch of tubes that are just exchanging temperature. So there's no moving parts there. If it's an energy recovery ventilator, there's usually a wheel, a desiccant wheel that is moving around. But again, the motors are extremely efficient. So they use very little energy, even though we run them all the time in these buildings. And then the other principle I mentioned previously is air sealing. So we want these buildings to be airtight because through the leaks is where we start to get trouble. We're either getting cold spots or drafts, or we're having air leakage come into the building and cause issues with moisture buildup, condensation inside our assemblies or on our surfaces. And when we're air conditioning a building in a hot climate or heating a building in a cold climate, we want to keep that space conditioning in the building. We're providing that either through fossil fuels, electricity, fossil fuels, or limited renewable energy on site. So it's precious. We don't want it to just leak out of the building. So passive design, way more so than any other sustainability and energy focused standards that are out there, has a very rigorous approach to air sealing, the most rigorous that there is, really. So those are just a few of the principles that we use. There are more, but that's a quick introduction to what they are.
Well, and I'd love to take a step back for a moment and just so basically what we're doing with passive design is take out the concept of how you're going to heat or cool the building for a moment in terms of the way that you're going to do it. Set that aside for a moment. It's about how we design and construct the actual building that allows us to maintain, I'll use the word comfortable, there's probably a better word, maintain comfortable temperatures, regardless of whether we're using gas heat, electric heat, geothermal, all those other things. The building itself does such a magnificent job providing consistent temperatures, regardless of what's going on outside.
That's right.
So even if we're starting to move toward extreme cold, or whether we're moving toward extreme hot, and let's say all hell breaks loose and our gas gets cut off, or our electricity gets cut off, or the geothermal wells don't perform, or something happens, right? The building itself is going to protect the temperature, the internal temperature, because of the way that it was designed, the beautiful way it was designed in terms of, the wall assemblies, which means, correct me if I'm wrong here, I might butcher this a little bit, but the wall assemblies, which means how the insulation comes together, the way that we use the insulation, the way that all the mechanisms that related to the wall, and then to make sure that those places that normally would introduce opportunities for air leaks, like when we put in a window's great, but a window often is a place where we get warm air if we're in a cold climate and it's cold outside, can leak out, or cold air can come in, right? I'm assuming. So it's just paying really amazing attention to design and then executing the design. And from what I understand, this doesn't cost a lot.
That's right.
I want to talk about cost in a second, but I can't stress this enough that we can, till we're blue in the face, we can keep coming up with more ways to heat or cool our house in energy efficient in an energy efficient way. But there's nothing maybe more important that we can do than just when we build, to build it properly. And that's what passive design does.
You've got it.
I'm trying to put it in the context of
you've got it.
And well, so talk a little bit about the cost differentials to build using passive design. And I also just want to say out loud, and we can get to the differences in a little bit. Passive design yes, it's for single family homes, but it can be used across every kind of commercial application as well, in terms of multifamily homes, in terms of hospitals or industrial buildings. I mean, it can be used in multiple different ways, but in general, can you talk a little bit about the cost differential to build in a way that has passive design versus?
Yeah, absolutely. So there are a few components that go into the consideration of cost. The first one would be the soft cost, right? Because we are paying special attention during the design process. So there is a little bit more thought and time that needs to be spent on detailing in the design process than we typically would see with conventional projects. But it's not much of an uptick. So I would say it's fairly inconsequential. There is the soft cost of having a passive house consultant, which if you're doing a single family home, that may run anywhere between, depending on the size of the home, it could be anywhere between $30,000 and, $50,000, something like that. If it's a really, really fancy large house, it could be more. But when we get into the large projects, it's a blip. It's a tiny little blip with the budgets of these larger projects. There are also costs of certification if a project decides it wants to pursue certification, which is a really fantastic idea if you want to make sure that the special attention paid in design and the special attention paid in construction are actually gelling, and that everything that was intended got into the building in the way that it was intended to be there. Having a third party verify both the design and the construction, it's really helpful for the homeowner, for the building developer to have that assurance. Okay, this is what we actually intended it to be. So there is a small added cost there, and that cost is usually per square foot, so it scales. but we're talking, cents on the dollar per square foot, literally.
Mm-hmm.
And then the largest cost addition is the materials. And really, we're looking at 3 primary areas where we're going to spend a little bit more on some projects and nothing more on other projects. And the determining factor between those two is scale. So when we're looking at a single family house, that's sort of our worst case scenario because we don't have economies of scale. It's usually, a bespoke design instead of something that is, modularized or scalable or repeating kind of design. And the surface to volume ratios for single family homes are also the least advantageous. So we need more insulation on those. We need better windows to create that resilient envelope that can cushion us from the shifts that are happening outside and keep that nice indoor environment. So on a single family home, what we have been seeing over the past 12 to 15 years of doing passive houses in the US is that there can be a cost premium anywhere between 5% and maybe at the very, very upper end, 15%. And this largely depends on which climate you're in, and it also depends on the complexity of the house, right? If you have a single family home that's all glazing, it's a glass box, you're gonna spend a lot more money, probably more towards that 10 to 15% range than you would if you had an intelligently considered design where you're being a bit more conservative with windows, and you have windows in wonderful places and lots of light, but you're not, trying to make glass walls. And then if we're looking more towards complexity in terms of the overall shape, a simple box with a nice volume inside, so a compact design, that's always going to be more cost effective. If we have a house in a cold climate that's very spread out and meandering, maybe it's a U shape, that's going to be more on that cost premium as well. Now, where we're seeing almost no cost premium is when we're looking at projects like large-scale multifamily, large-scale university dorms, non-residential buildings, where really we're not spending any more on the insulation, the air sealing, the windows, and the energy recovery ventilation than we would be spending on the envelope and the systems if it was conventional. But what's happening is they flip-flop in a way. So on the large-scale buildings where we may be doing more insulation and better quality windows, we have such marked savings on the mechanical system sizing that the savings on that equipment side is paying for the increased attention to the envelope. And really what we've been seeing in the large scale is less than a 1% cost premium for doing not just passive house, but the passive house pathway to net zero energy. So net zero energy buildings at less than a 1% cost premium. So scale is where it's at. And that's actually where I've been focusing for, the last 8 or 9 years is doing passive house at scale. I do have a passion for the small scale passive house though, and especially affordable housing applications of that. So I'm sort of, I'm at both ends of the spectrum in terms of size. But yeah, so it's very exciting to know that we have the technology, we have the building science know-how to do zero energy buildings that don't cost any more than conventional buildings.
So there's so many places I want to go with what you just said, but let's stay on cost for a second.
Sure.
So you just explained that on a single family level, the costs might be between 5 and 15% more in terms of construction costs. Is that correct?
That's correct.
And then on a larger project, like a multifamily project or dorms or a commercial use, it could be almost nothing in terms of additional costs because of where you're saving in terms of you're saving on mechanicals and space required for mechanicals, and that offsets the additional costs for the higher end windows and the insulation, the additional insulation required. So let's flip that to the other side of the equation now. When you do these things, because this kind of gets back to what I was saying earlier, like when we create a building that automatically stays at a more consistent temperature, that means we're less reliant on heating and cooling needs. So therefore, no matter what, we're going to save some money on that end. So we might, even if we spend more on the upfront in terms of construction, which it sounds like with the larger scale projects, you really don't, but talk about the flip side in terms of what it means first on just the reduction in energy needs overall and how that might compare to more conventional construction. Like what kinds of energy reduction needs are we seeing, and how might that translate to cost?
Yeah, absolutely. That's a really important question. So even on the single family and the smaller multifamily, where we do have a higher upfront cost premium, what we do realize over time is a significant return on that investment. So our operating costs are much lower. And if we start doing life cycle cost assessment and look at net present value, these projects are still very attractive if people are owning them and operating them. Typically, what we see, and I'm going to give a range and then explain the size of the range. We see an energy cost reduction for space conditioning of between 60 and 90%. Now, 60% would be in climates where we just don't need that much space conditioning, right? So, we don't have a lot to begin with, and we're saving some on that, but the energy recovery ventilation is not as necessary. We don't have as much of a delta T or a temperature difference to cover. On the higher end, those 90% reductions in the need for space conditioning energy, we're seeing those in places where we would do a large-scale multifamily building. We don't have hardly any upfront costs to begin with anyways, and then the operating costs are, the utility bills are nothing, because in a cold climate, say this example is in a cold climate, we get to preserve all of the energy we're putting into the building, all of the internal gains coming from people. So these buildings are essentially heating themselves. They really are heating themselves.
Yes, and because and just as we think about that, because there are so many people in the building, and there are so many appliances like stoves and refrigerators and things along those lines that throw off heat, we're able to use that heat, contain it, because we're not letting it all leak out. And so, is that part of how that works?
That's absolutely correct. Yeah, we're not wasting any of the useful internal gains. They're being recovered in the energy recovery ventilation and put into our incoming fresh air. And yeah, the same with all of the gains from people, the phantom heat, all of that is useful. Yeah.
Now, when you say 60 to 90%, is that compared to, more conventional construction? How does that compare to like a LEED certification? Just so people can understand like the levels that they might go and the gains they might achieve.
Yeah, that's also a very good question. So 90%, that really would be compared to existing building stock. When we're getting into the middle of the range, say in the 75% range, that used to be when we were looking at code compliance. However, a really interesting thing is happening in the last number of years, which is the codes are taking inspiration from Passive House, and we now have several jurisdictions in North America where passive house is becoming code. So that difference between what's code and what's passive house, it's becoming quite small to non-existent. Which is, I mean, that's what we always wanted, was for passive house to just become the norm, because it's not complex,
Right.
it's just good building science. So if we were comparing to LEED, what happens with LEED also is that every few years they change their reference code. Right now, depending on whether you're LEED version 4.1 or you're LEED version 4, you may either be using ASHRAE 90.1 2016 or ASHRAE 90.1 2019. And the percentage difference is fairly close on those two, and it depends on the building typology as well. But we might see something like a 30% uptick from, a good LEED building, say a LEED silver, or maybe even a LEED gold, up to passive house. And actually, there has been some really nice reciprocity that's been happening between the GBCI and the LEED rating systems, and also the Living Building Challenge and their energy pedal with passive house, because when you do passive design or passive house through PHIUS, you essentially earn all of those energy credits. So,
can you explain what PHIUS is?
Yeah, so PHIUS is the organization in the U.S. that's based in Chicago, headquartered in Chicago, that works actually internationally, but has the strongest presence in the U.S., with some presence also in Canada and in Mexico. And they set the passive house standards for North America and pretty much anywhere in the world that wants to use climate-specific passive house standards. There is another approach to passive house that comes out of Germany that's less focused on climate specificity. It's more of a standard where it's like one size fits all, and there are slight variations. PHIUS is a standard that is much more focused on your particular building and your particular climate on your site with your occupants. So it's much more acknowledging and customized and optimized for your particular building. And they both use the same building science principles. The PHIUS approach is just more customized, so it ends up being more cost effective.
Oh, that's really interesting about the Germany. Actually, Germany was on my list of things to ask you about, because I know that they've been taking a passive design approach to engineering homes for a long time, and more robustly, more robustly in terms of quantity. So I guess that does lead me to my next question, which is, I know you mentioned there are certain municipalities or certain areas that are incorporating passive design into code, into the code. But really, I think one of the reasons I wanted to have you on is that it still seems that the U.S., the United States, has been relatively slow to adopt passive design principles in comparison to certain parts of Europe, and especially given what we're facing with the climate, both in terms of what we're trying to do in terms of addressing climate change, but also in terms of again, people's financials, in terms of building resilient houses that even, again, if everything goes crazy with the grid, you're still going to be okay because your building design is good. I actually want to get more into that in a little bit, but why do you think, I'm telling you right, Why do you think, I still run into a lot of people where this feels like uncertainty to them. They don't understand it. And again, it's one of the reasons I wanted to have you on. But why do you think we've been slower in the United States to adopt this very basic, solid engineering that can accomplish all the things we say we want to accomplish?
Because we're Americans. Americans in general are very independent spirited, I think. And not to get too political, but I think there's a much longer history of more sort of socialistic types of perspectives in government in Europe. And I feel like one of the things that maybe was, I won't say it's a misstep, because I think everything happens in its own perfect time, in its own perfect way, but when Passive House came back to the U.S., because it started here in the 70s during the Carter administration, and here and in Canada with the low-cal homes and the sort of original Passive Houses, and then, the inspiration was taken up by Bo Adamson and Wolfgang Feiss when they were working on a project for China, and then they took all of these principles they had collected from everywhere, great building science principles, and they codified it, and then it came back to the U.S. in the form of the PHI standard and approach. When it came back, what happened here in the U.S. was that the first adopters, we didn't really grasp that because of the way Americans are. We definitely have a few different sort of approaches to energy in this country. And some folks really feel like energy independence is something they value, and it's an important part of security for your family and your community and your city, your country. And then there are people who are more focused on the collective and climate change and habitat. And oftentimes these people they get in arguments and they don't really agree. And one of the things that I feel like we're still struggling with a bit is to really grab people's hearts or grab their emotions around this and make it personal for them. And I know that sounds strange, talking about a building science-based approach to having a comfortable, healthy, energy-independent type home. But they're our homes. They're the buildings we work in. So they're part and parcel of the fabric of who we are in our community. And I just, I feel like there's a lot happening in this country right now. And even in terms of the media that is separating people further, I feel like the reality is we're all somewhere in the middle, and we all agree much more than it would seem. And there needs to be like this middle path to explaining this building science where, everyone can understand it's good for everyone. It's good if you want to be energy independent and, run around with your guns and whatever else. And it's great if you want to help save the planet and prevent climate change. And it's good for all of those reasons.
I think you bring up an excellent point, because it shouldn't be political, because as you say, it really solves many sides of the political equation in terms of, again, if you are about self-reliance, right? If you are about self-reliance, which sometimes gets affiliated a little bit more with the right, right? If you are about self-reliance, you want to build a passive house. You want to build a passive house because you will be able to be self-reliant no matter if the grid goes down, energy gets cut off. You're not reliant on other countries for things like, so to me, the fact that if this science, this building science has gotten lumped in more with progressive left, which, is also a beautiful thing. I mean, I love the fact that this, reduces our impact on the climate. But I cannot for the life of me wrap my brain around why anybody on any side of the political spectrum wouldn't embrace this, because this does make us self-reliant. This does make us energy independent. We are not reliant on other countries. We get to take care of ourselves by building a house like this, or by building housing like this, or buildings like this. So by building hospitals like this, to have a hospital like this that is not reliant on like extreme, temperature shifts. This is not a political issue. This is a engineering issue. That's just it. I mean, that's the beauty of energy engineering. Engineering is above politics. It should flutter above it. And that's what this is. This is great engineering that everybody should be embracing. So, I'm gonna actually throw out a couple of other things that in my head I think are sort of barriers to passive house, and I just want to get your read on that. So this is a little bit of pushback, but sometimes I think passive house and people, when they think of passive design or passive house, they think of not attractive housing or not attractive buildings, right? They think of just not aesthetically pleasing, not welcoming, not, how do we overcome that piece? Because I actually think that is more of a barrier than most people give credence to. If you could point to the most stunning building, right? The most stunning either house or multifamily building, if you could point to it and say, guess what? That's passive design. I mean, I think it's a game changer.
Yeah, I know that there definitely is that misperception. And again, I feel like those of us who were the first adopters, we made a few mistakes, and some of those mistakes were, sort of showcasing these buildings that were, boxes with not too many windows, or, pointing to examples in Germany before we had many here that were like that, and thinking that that's the way it needed to be, or folks that we were trying to convince to do passive house thinking that's the way it would be. There's actually a really funny moment in one of Trump's speeches a while back where I couldn't believe it. I was like, holy cow, passive house has come to the stage. And he said, and we're going to do those super efficient houses that have no windows. And I'm like, he's talking about passive house. He's got it all wrong, but he's talking about passive house. Damn it. But that's just it. It's like, that's the misperception. But passive houses can look like a normal house, anything you want, really, a normal house.
Right.
Yeah. So,
and the window designs, the engineering of the newer windows, the triple pane and everything else is so good that you can use, if you want, larger windows, lots of windows. And obviously there's trade-offs with every decision you make, but it can look any way you want. There's going to be a premium on some of those costs, because the more glazing you have at a higher price point window, then that's going to take up the cost. But I do feel like that is out there as a barrier. And I can see it in people's faces every time I talk about passive house, and they bring up examples of certain buildings, and I'm like, it doesn't have to be that way. Okay. So here's another thing. I think, and this is just my subjective, opinion on another area where passive house, why it hasn't been more accepted across the country. I don't know, and this kind of ties into the last thing. I don't know that the branding has been great. And I hate to use the word branding, because personally, I really hate branding. I respond to things where there's not branding, right? But I think even the name, which I know the name has changed a bit. I think they've changed from, it was passive house, and now it's moving toward passive design. Is that correct? Or is there some stuff going on with that?
So PHIUS is no longer Passive House Institute US. That's what it used to stand for, PHIUS. So it just became PHIUS. And the terminology that we've been using now is passive design and passive building. Right. But even the word passive. I mean, I think you
Exactly.
summed it up well in terms of like, well, what we're talking about is the building there's passive survivability there. You don't need to do much to it, and it's still going to be a lot more comfortable and resilient than anything else. Because essentially your building envelope is acting like part of your mechanical system. But yeah, we've had, at board meetings and technical committee retreats and stuff, we're like, how do we make a better name?
I mean, the word that came to my mind, and I've not given this a ton of thought, but like when I think of passive house, I think of resilient housing. Yep. And resilient is a word that I think everybody feels drawn to a bit and can wrap their, and wants in their life and for themselves. And when you think of the word passive, it's just like, it feels a little vague and evasive. And what exactly does that mean? Whereas if you're going to build a resilient house, there are these things that you do, 1, 2, 3, resilient house. Now it's resilient against the, temperature extremes and climate extremes, and allows you to do a lot of other things. Anyway, that was just, take that for what it's worth. But I've been, again, trying to take note as I've been having lots of, discussions with contractors and builders and MEPs and the general public about this in terms of like what seems to be the barriers. Okay, so tied to everything we were just saying, I'm going to let you just comment on this. And I alluded to it already. But if I said passive design is a matter of national security, what would you say about that?
I would absolutely agree with you. I feel like why the heck are we wasting our time on and spinning our wheels on so many other issues where, I mean, energy security, it's a big deal. And yeah, the oil companies, they're going through tar sands and that costs a lot of money. And to the extent that we need to rely on fossil fuels coming from other countries, that's a weakness. Because we saw during COVID supply chains fall apart. We've seen what's happening in the Ukraine. It's a big deal. And even, you hear some preppers talk about, well, the grid of our country, it's pretty fragile. And there's, it wouldn't take a whole lot to bring everything down because it's so interconnected. And aging as well. And we're putting a lot of pressure on it with inefficient buildings, adding more inefficient buildings. So I think it's absolutely an important part of security, of national security. And even I think the Department of Defense thinks that it is. There's been some interest there, and the Army Corps of Engineers has sent people to certified passive house consultant training. We've got a fellow on the PHIUS Board of Directors who goes and lobbies on the Hill, and he's got some contacts in the armed forces as well. So it's coming. It's just not, it's not being adopted quickly enough, in my opinion. But I will say, I feel like with places like the state of Massachusetts and the state of New York really pushing their codes to a place where in some ways they're pretty equivalent to passive house, that's all going to start shifting. So
I'm so glad you brought that up, because I think the thing we didn't talk about is one of the other barriers is contractors not knowing how to do this, and therefore, I don't want to say resistant, but they're under the gun and under deadline and have to deliver their products on time and on budget and introduce something that's new to them, even if it's old and proven building science, but it's just not the way that they do it in that region, right? So even if you want to build a passive house or a passive multifamily building, and you try to get a contractor to do that, a lot of them are resistant until, and this is where Massachusetts got it going on, right? Until they've had exposure to it once or twice. Like at first it's like, oh, I don't know that we want to do this. And then they work with the consultant and the certifier, and they learn how to do the wall assemblies, and they do it on one building, and now they're ready to go. So part of it is training the trades. That's right. And getting them comfortable with it so that when a consumer actually goes to the trade and says, I want to do this kind of building, they're not met with, no, we don't do that, or we don't do that around here, or there are other ways, or whatever. Instead, like it's very symbiotic that I go to a builder and want to do this, and they're like, yes, I've done this before. I can do this. And so that's what's happening in Massachusetts. In some of the other states where they're, because of are they doing it through incentives? Are there incentives that they are providing?
It's both carrot and stick. It's incentives. Mass Save has a lot of great incentives at every level, from single family to sort of double decker, small multifamily on up to large scale. And also the stretch code, which is already being, early adoption is happening by some of the jurisdictions within the state of Mass. So it's all happening, and I think you're absolutely right. I've experienced the same thing because I've been doing passive house for so long, and I've done many firsts. The first super large scale one in the country in Kansas City, first non-residential passive house building with curtain wall on it. Some of what I've encountered is working with these construction companies where they're like, we don't know anything about this, but we're doing it. And I tell you what, once they go passive, they don't go back. It's really hard to go back because suddenly the builder is always very, very important, but they get to bring back a nobility to the trade. Like they are instrumental, really, in helping move this whole thing forward. And knowing how much of a difference they are making down to the guy that's attaching the drywall to the studs and making sure it's got extra ceiling around the edge. At every level, whether it's, the last guy who just started in a new trade that's working on a passive house envelope, or a construction manager of a very large construction firm, taking pride in the fact that, he is the air boss. He's the air sealing boss on this first large-scale passive house in this jurisdiction that's never done it before. It's friggin' exciting. It's a big deal. And I think that that sort of contagious excitement and pride in what they're doing, it's something that's really good. And even though there are a lot more women in the trades these days than there used to be, it's still primarily men. And our men need things to be proud of and feel good about. And, that job of building really super efficient buildings and retrofitting our existing building stock for successive generations and having the confidence, because we've used building science, it's going to be there and it's going to perform. That is a noble, honorable trade, and it's really important.
Well, and so then what happens in Massachusetts with the carrots and the sticks is, because more passive buildings are going up, more contractors are becoming comfortable with it, not only comfortable with it, but as you said, excited about it, trained in it, and it just spirals from there. So I am super excited about the future of passive design, and I will be shouting it from the rooftops as long as I'm on this earth, because I am just blown away by this technology that is right there for us to use.
Yep.
Okay, so what drew you personally to it? What personally drew you to passive design, and where do you see yourself like moving forward with passive design?
I had been my first profession. I was a dancer. I was a ballet and modern dancer, and I always had a strong tie to the environment. Maybe because of working with my body. I did like non-traditional medicinal kinds of things, herbs and vegetarianism and that stuff. And so it just sort of bled in to this general concern and compassion with respect to the other creatures that share our planet with us. And I have a pretty technical mind. And after my dancing career was over, when I was about 30, I ended up sort of, taking a foray through the natural foods industry. And somehow I ended up starting different green teams at different companies. And I ended up working on building projects, energy efficiency projects. And they just lit me up, Kathleen. They really did. And I realized, I'm a numbers gal. I really love the numbers. I love where you can have a measurable impact, a before and after, and you really get to see and experience the difference that you've made and quantify it. And I was doing energy consulting, and I started working on lead projects and doing lead energy modeling, and then I found Passive House. I think I found it in 2010 or 2011, and it took me a while to get organized to be trained as a Passive House consultant. But once I went through that training and, got my teeth into the underlying science, which really, it's pretty simple algebraic equations. That's what building physics primarily is, until you get to the combined heat and moisture transport, and then it gets complex. But it was just so exhilarating to see this horizon in my mind of like, oh my gosh, this completely works. We can measure it. It's simple. It's easy. It's not nebulous. It's really well defined. And I never looked back. It took me a few years to figure out how to stop doing other kinds of work. But from the time I found Passive House, that really has been my singular focus. And so I started with single family homes in the San Francisco Bay Area, and then, gradually moved into doing some of the first multifamily and then some of the first non-residential stuff. And I was one of the founding members of the PHIUS technical committee and have served on their board of directors for, forever. And so really where I see myself going is continuing on the path that I'm on. I've been working for larger engineering firms for the last 5 years, because as Passive House sort of, came to the forefront, these larger engineering firms realized, we need to be doing this. And so I've been helping these engineering firms tackle it and build Passive House teams within them. And so I just started with a firm that I've been wanting to work for probably 8 years, Thornton Tomasetti. And they do a lot of large-scale buildings. And one of the things they focus on that I haven't had the pleasure of working too much on yet are K through 12 schools. I'm really excited about that. Yes. And I'm also very passionate and excited about affordable housing. Now, Thornton Tomasetti does some affordable housing, more large-scale multifamily stuff. And so I hope to continue doing some of that. But for me personally, what I'm really excited about is working in my local community in my small mid-coast region of Maine and actually getting some developments going here, just starting with a demonstration development of smaller scale homes, not tiny homes, but somewhere
Right.
between a tiny home and a reasonably sized single family home. Because people in Maine don't really love living in multifamily buildings. They want their own house. It's just part
Right.
of the culture.
Yeah.
But putting together a demonstration project where we have several essentially zero energy passive houses at small scale that are absolutely affordable for people, and working with builders in the area to put together some panelization approaches, really trying to regionalize the supply chain so we don't have to waste money on transportation, and it's resilient if supply chain shuts down and we're not getting things shipped from other places because there's no diesel fuel or whatever else could happen. So that's definitely something I see for my future, is starting to get into the development side of things, because, by now I've worked just as a passive house consultant on my own with my own firm. I've gone into the larger engineering firms working with structural engineers and building scientists. The last firm I worked for was a pretty large mechanical, electrical, and plumbing engineering firm. And so I've sort of, done all of the different parts of it. I haven't gone to work for a developer yet, but I've worked with enough developers, and I'm interested enough in the financial piece of things. And I'm like, I can figure this out. I can start putting together the right people to make something happen. So yeah, that's where I see things headed. And really, one of the alignments that's also happening is a subgroup of the PHIUS Board of Directors is actually forming a community housing development organization. And it's just in its nascence right now, but what we're hoping to do with it is to be a technical resource for folks in all different places around the U.S. who want to do developments with smaller scale homes, and help them understand, okay, what are your resources? What's the most cost-effective way to do this? Can we help you fundraise? Can we use the PHIUS sort of brand and name and reputation to help you get this off the ground, and help people so that they don't need to reinvent the wheel? Because we've got a really great recipe already, especially with the prescriptive approach to passive design, that this shouldn't be difficult to do. So I'm very excited about helping in that regard however I can, because housing it's an issue everywhere. It really is an issue everywhere. And as energy costs skyrocket, especially in our climates where we have really large cooling loads and really large heating loads, and the climate is shifting, we need to find ways for people to be able to have homes that aren't costing them an arm and a leg to keep comfortable. Yeah.
Right. So, last question. You've lived a rich and interesting life and do interesting work in the world, and I like to ask guests for a book recommendation.
Yeah.
And it doesn't have to be anything to do with passive design. If you don't, it can be anything. Just what book has moved you?
I read so many books. I thought about this question when you sent it ahead of time, and probably one of the most influential books for me has been, and I'm going to forget the name. I might have to get up and go grab it because I put it in my bag. It's essentially a book about lean design and construction. Let me grab it really quick.
Yeah, grab it. Yes.
This is it. Transforming Design and Construction.
Great.
Yeah.
A framework for change. I am getting that one.
So it's
what was it specifically about it?
So I have a very I have a very organizational mind. One of the things that I really enjoy doing is systematizing expertise so that people who don't want to wade through the learning curve can apply expertise learned over years much more quickly. And one of the things about this book that I really loved is it gives frameworks for organizing not only how companies who deliver design and construction work, but organizational methods for organizing projects themselves. And it's just eminently logical. And it really focuses on efficiency and not wasting effort. And one of the forces that I feel at work in my life is a sense of urgency about doing the work that we do, and an awareness that there are not nearly enough people in my industry to do what needs to be done. And so the idea that we can leverage organizational methods of applying expertise without wasting time is something that really gets me going. And it's, it's a little nerdy, and it's probably a little bit dry for a lot of people, but I feel like you can open to any page of the book and immediately get ideas that you can apply almost immediately. One of my favorite ideas is the concept of standard work. And it's something that's used in lean construction or lean manufacturing. You know, this is, if folks know about Sigma 6 or any of that stuff, lean construction is just it's a furtheration of lean manufacturing practices applied to the construction and design industry. And so the concept of standard work is, if there's something that you find yourself doing again and again, streamline it, systematize it so that you can have a process of continual improvement and you don't need to reinvent the wheel every time.
It's like the iterative process of software development, right? That you're always learning from what's working and not working and building on that in very small incremental ways until, 6 months later you have a stunning, product.
That's right.
So it's like taking some of that from and applying it to this. Well, this was a lot of fun and very informative, and I'm grateful you're out there, and I'm also grateful to have more females.
Yes.
For females in this industry. And so
Agreed.
Thank you. Thank you for everything you do.
Likewise.
I appreciate your time with this interview, and I appreciate the work you're doing in the world.
Thank you very much, Kathleen. I really appreciate you inviting me, and it's really been a pleasure chatting with you.
Thank you for listening or watching and sharing. This is the Kathleen Sessions podcast. You can find me and all of these episodes at theKathleenSessions.com or on your favorite podcast app or on YouTube. Have a stunning day, everyone. Bye.